Hi guys, today we're going to be looking at the third series of examples on projectile. So here's the first question we have today. A body is projected downward at an angle of 30 degrees with the horizontal from the top of a building 170 meter high with an initial speed of 40 meters per second. How long will it take the body before striking the ground? So the first thing we have to do is to get a pictorial interpretation of this very question to help us understand what we're about to do. So don't forget, the body is being projected downward, unlike other kinds of examples we've worked on in the past. Bodies were projected upward at an angle with the horizontal, but this time the body is being projected downward. So let's see what we have here. Let's see how we can interpret this. So first of all, let's draw the building. Let's assume that we have a building like this, and the building is 170 meter high. That's the height of the building. Now somebody stand here and project a body down, an object. The body could be anything. It could be a stone. It could be whatever it could be. It could be something, actually. But the person does it against the horizontal. Please, you have to know that this horizontal, this is vertical. The person does it against the horizontal at what angle? 30 degrees. Now, with what speed did the person do it? The person projected with a speed of 40 meters per second. So that's the first line of interpretation. And don't forget, this is not like the other ones that we've been doing, although there's a lot of similarities between them. Or like other ones, the bodies were projected upward like this. But this time around, the body is being projected downward at an angle of 30 degrees with the horizontal. So the first thing we're going to do is the same thing. We're going to look for a way to get our initial speed or velocity along x-axis and along y-axis. That's the first thing we have to do. So this is the height of the building, and then we're asked to get how long it's going to take the body to strike the ground. Now, this is not range. We're not talking about range here. For range or maximum height, the body first of all has to get the max height. But this one, we're not talking about range. We're talking about what we can call trajectory. Instead of trajectory, we're talking about because questions on trajectory are quite very tricky. So the first thing we're going to do is they want us to get the time it takes the body to hit the ground from this place. Now, don't forget, whatever time is going to take the body is going to be the same time, for everything along x-axis and everything along the y-axis. So it's going to take it the same time for the body to cover this height, 170 meter, and some distance on the ground. So it's going to be the same time. So we are given the height of the body, that is distance along y-axis. So let's get our, what are they calling it? Let's get our resolution of our component initial speed. So here we have 40 meters per second at 30 degrees. So don't forget the component. So initial speed along x, initial speed along y. So this faces your opposite hypotenuse. That's uy over 40 equals to sine 30. Is the first thing we do, very important. So initial speed along y-axis is 40 times sine 30. That will easily give us 20 meters per second. So the body moves, when the body was projected with 40 meters per second, the body came down like this with this initial speed. So quickly, let's get that of x. That of x is 40 times cos 30. We all know that. That's 40 times 0.8660. Let's use our calculator to get that sorted. Use our calculator to do that. So what do we have? That's 40 times cos 30. We have 34.6. That's 34.6 meter per second, about 35 meter about 35 meter per second. That's what we have, approximately. So we have our initial speed already. We know what we're doing. To get the time, don't forget that the formula for trajectory is simply this. Distance along y is distance along x times theta, like this, then plus 1 over 2 times gravity. Then the t squared that we have, don't forget that time, is, what do we call it? We have s equal to ut plus half at squared, distance along the y-axis. So we have the distance along the y-axis, this u cos theta times time. The Bible says about u cos theta. So the time is distance squared over u squared cos squared theta. There's a formula here. Now they want to get the time. There's no way we can get the time from this trajectory formula. It's not possible. We can't really get the time from this, but we can get the time using using the individual component. We can get the time by considering this. You can get the time by using this, easily. So there's no need using this because there's no provision for the time. What we can use this to get is to get the distance the body covered on the x-axis or on the y-axis easily, or the angle of projection, or even the initial speed. This formula is such a wonderful formula. So quickly, let's get the time. The time it took the body to strike the ground. It's going to take the time it's going to take the body to strike the ground. It's the same time it's going to take the body to cover this height of 170 and the distance of some distance along the x-axis. So what do we do? Quickly, don't forget initial speed along the y-axis is 20 meters per second. If that's the initial speed, then acceleration along the y-axis is going to be plus gravity, positive gravity, because the body went down like this, obeyed gravity. Now, is the time they want us to get? We don't know what it is, but we know the distance along the y-axis. This one along the y-axis is 170 meter. So distance along the y-axis, acceleration along gravity, is 10 meters per second squared. Positive one. The time is what we are looking for. The initial speed is 20 meters per second. Now, it's very easy for us to use stuffs along the y-axis because we have the distance along the y-axis. There's no distance along the x-axis, but we could get that easily using this formula. And once we get that, we can also carry on using the other formula, the t equals to distance over u cos theta. You could use this formula, whichever way we want to do it. But first of all, we just have to get the time. There's only going through that stress. Let's just use our equation of motion. What do we have? S equal to ut plus half at squared. S equal to ut plus half at squared. So the distance, 170 meter. Initial speed is 20 meters per second. Times the time we are looking for. That's what we're looking for right away. So that's 1 over 2. Acceleration to gravity is positive because the body got projected down, came down in obedience to gravity, 10 meters per second squared. And still the time we are looking for. So 2 year 1, 2 year 5. So what do we have? We have 170 equals to 20 plus 5, 20t, I beg your pardon, plus 5t squared. This is a quadratic equation. So 5 year 1, if you do not understand quadratic equation, you won't be able to understand what we're doing right now at this very stage. I've taught this already in the previous one of our previous lessons. You can go ahead and study that. So this 34 we have here. So what do we have? We have t squared plus 4t equals to 34. So you may have to come up here and use the space up here. Use a formula method to solve this, although we've not taken the formula method. We use the formula method to get this sorted. So what do we have? We have t squared plus this t squared plus 4t. Send this one to the other side, minus 34 equals to 0. So a is 1, b is 4, c is minus 34. That's what we have. So the formula method, minus b plus minus square root of b squared minus 4ac over 2a, square root of discriminant. So minus b is minus 4 plus or minus square root of 16 minus 4ac, 4 times minus 34 over 2 times 1, 2a. So we've almost gotten our time. Almost gotten our time. Almost gotten what we're looking for. So what do we have? This minus 4 plus or minus this 16 plus minus and minus is plus. So 16 plus 4 times 1, 4, 4 times 34, 4 times 4, 16, 4 times 3, 12 plus this 13, that's 136 divided by 2. What do we have? Minus 4 plus or minus square root of 16 plus 136 will give us 152 over 2. So quickly, we're going to use our calculator right now. So the square root of 152 gives us 12.3. So that's minus 4 plus or minus 12.32 divided by 2. So minus 4, 12.3 divided by 2, or minus 4 minus 12.3 divided by 2. Minus 4 plus 12.3 will give us what? Plus 8.3 divided by 2. Or this minus 4 minus this is minus 16.3 divided by 2. We don't need the negative result because our time cannot be in negative format. It has to be a real number. So 4 in 8.3, 2 in 8.3, I beg your pardon. That is 4.12 seconds. So it took this body 4.12 seconds to heat the ground. It's as simple as that. So that's that for this very first question under the first series. So if you enjoy this very lesson, please subscribe to this very channel and share this lesson with others. See you in the next one. Thanks.